everyone, welcome to my channel. So in this video I'm going to cover the solution to this question, and also at the same time I'm going to cover the general process we should follow in a real coding interview at the end of this video. So before we start the real content for today, I would really appreciate that if you can help subscribe this channel. So let's take a look at the question. So given an integer array nums which is sorted in ascending order and all its elements are unique, and given also an integer k, return the case missing number starting from the leftmost number of the array. So it says that the input array is in ascending order, all the elements are unique, and also the input array is never going to be empty. So what we could do, the first brute force solution is we could do one pass through the array and record down the missing numbers etc, and then we can get the case missing number. But that one is going to be all of n, which is a linear solution. So n is the length of the array. So but when it says that the array is in sorted order, and then we are finding the case whatever case number, like the missing number whatever. So usually we could leverage binary search to solve this kind of the problem. So sometimes it is pretty obvious to do binary search, but sometimes we need to do a little bit of the transformation to do the binary search. So it's like in here, we need to do a transformed binary search. So how we do this binary search? So for each of the place, we could transform into how many numbers are missing at this place, because if we transform to that kind of array, then it is also going to be in non-descending order. So you can apply the binary search on top of that. So how to compute how many numbers are missing at the current place? So essentially we need to, so let's take the 7, this one as an example. So at current place 7, we are missing two numbers, 5 and 6. So what we need to do is we calculate the distance between the current number to the start number. So the distance is 3, and also we need to minus the index of the current index, which is 1. So then we have 7 minus 4 minus 1, which is 2. So that's essentially how we compute how many numbers are missing at the current place. So you may wonder why that is a formula. So that's essentially that's about to see how many numbers are there that should be within this range between 4 and 7, and what is the current index. So if we have the index as 1, which means there are two numbers, 4 and 7, and actually we need to have 4, 5, 6, and 7. We should have 4 numbers. So this means 4 minus 2. So that's essential. That's a general idea, the intuitive how we compute the missing number at the current place. And if we have that kind of the array, so what we are going to do is we can apply a binary search on top of it to try to figure out the place that is missing case number. And after we find out that, we should be able to find the case missing number very easily. So let's go through this piece of code. So first of all, we need to care about the edge case, which means the last number in the array is still missing smaller than k numbers. So let's say it is 1 to 4. For the example 3, for the last number it is missing one number, which is still smaller than 3. So what we are going to do is we need to have the last number plus the k minus how many numbers are missing at the last number. So like for this one, here we are missing one number, which is still smaller than 3. So it is 4 plus 3 minus 1. So 4 plus 3 minus 1. 4 is the current number. 3 is how many numbers? 3 is a k, and 1 is how many number are missing at the last position. So 4 plus 3 minus 1, which is 6. And otherwise, we will need to do normal binary search. So we have the left pointer, right pointer, we compute the midpoint. So if at the midpoint we are missing less than k numbers, then we are going to move our left pointer. Otherwise, we move our right pointer. And at the end, the left pointer should have, so at the left pointer we should be missing equal to k or more than k, more than k k numbers. But the number that is to the left of the left index, it should be missing smaller than k numbers. So what we are going to do is we have num, which is similar to the line 10. So we have the current number, and the plus the number is plus the k, which is the case missing number, and this one is to compute how many missing numbers are there at the current place, which is left minus 1. And then so I would say this is so this is the lack of the missing number and plus the current number at left minus 1. So that's the final answer we are looking for. So so that's pretty much it. It's a log-in solution because we use binary search. And at the end of this video, let me also cover the general step you should follow. So usually we should first understand the question. So please don't start to do the coding part too quickly. Try to understand, ask clarification questions, think about some edge cases. So for example, this one, this is an edge case we need to definitely think about. And the other thing, the next one is about finding a solution. So for the finding solution part, you discuss with the interviewer about the solution, how he solves the problem, do some runtime space analysis, etc. So get an agreement before you start to do the coding. So for coding, care about the speed, the readability, and also write the right version of the code. And at the end, you need to do some testing. So please don't forget to do testing as well. So that's pretty much about the general procedure, how to solve the problem. So so I try to have a mix about live coding and just explain the code that's already there. So feel free to tell me which version you like better. So if you like left coding version, or if you like that explain the piece of code, which may save your time. So feel free to leave some comments. And also, if you have any question about the solution to this question, feel free to leave some comments below as well. If you like this video, please help subscribe this channel. I'll see you next time. Thanks for watching.